doesn't work, then you know what, that's just too bad. All right, so we're going to do graphical statistics today. So statistics are going to be the rest of this chapter, but they split it up. Today is graphical. Graphical. Make sure I spell that right. Terrible speller. All right, so here we go. Now, I'm going to do a little introduction, and then we have a bunch of different stuff to go over today. So a little intro into what statistics are, okay? I'm not going to need you to know, like, all these words. I just need you to know, like, when I talk about it. So when we talk about the word statistics, statistics are very big right now, okay? Lots of courses being offered, especially in high school, AP Stats, if you want to take that. But really, it's to, basically, you have some data, or data, whatever you like to say. I like to say data. You have some data, and you're going to communicate this to others somehow. Communicate to others. So, like, for example, when we have our open house for people that we're trying to get to come to our school, we show some statistics of how awesome our math department is. We show how great our scores are on our AP tests, and it's true. And we have this bar chart, and we also have this little thing that shows how great we are according to the rest of the world, you know, stuff like that. Okay, but that's data that we're communicating to others. Like, look at our data. Now, you can have some variables. They can be either categorical or quantitative. And I'm not going to get into that because we're not really going to do that too much. So you could also have stuff as a bar chart. Okay, that's how you can graphically represent some data. Or you can also have a pie chart. Okay, I saw a really funny pie chart the other day. You don't have to write this down, but it looked like this. And then it was like green. And then this part was red. And the question was, will the Capitals win the Stanley Cup? And then green was no, and red was no, but in red. It was so funny. Come on, really? No, pie chart is really supposed to be, you know, yes and no, but it was like no and red. Anyways. And then a bar chart. I don't know if you know what a bar chart looks like. My kid, they did bar charts like in preschool. It was so cute. It was like these were the green apples, these were red apples, and these were, yellow apples. I did not. I did not mean to.
It's so fun.
My face is so bright. Anyways.
Yeah, they're gay apples.
Okay. Anyways, but like 8 people like the green ones and like 3 like the red. Anyways, you understand what I'm totally not going to post this video. Okay. All right. Now. Let's move on. I didn't mean that. And look at in my pie chart on my stuff, it's like blue, green, brown, other. And I totally went off like course thinking about real life stuff. Okay, here we go. Now we're going to do some stem plots. Stem plots, okay? Whew, that's fun. See, you're not bored. You're having the best day of your life right now. You're living your best life. Okay. Now, a stem and leaf plot is going to look like this. There's going to be a stem, and the stem is going to be the initial digit. The initial digit. Okay? And then the leaf is going to be the final digit. The leaf is the final digit. And so, we're going to look at some data points, okay? For 693, oh geez, really? We're not doing that one, are we? No. We'll do, oh, wow, it is that one. Okay, so there's this huge list of stuff. There's a huge table, and they say to make a stem and leaf plot for this. I'm going to start it off and show you how to do it, but we're not going to do the whole thing. It's insane. All right, it says table 10.3 On page 693, if you wanted to look it up. If you don't, that's okay too. But on page 693, table 10.3, there's some information, and it's about a state's population that was 65 or older in the 2010 census. And it says, make a STEM plot for this data. So let me go ahead and show you what this says. It says Alaska. Alaska had percentage of people that were 65 or older. Is that Alaska or Alabama? AL? That's Alabama. Yeah. 13.8%. Alaska is AK. Alaska was 7.7%. See, old people, guess what they don't like? The cold. What? Young people? That's true too. But they don't like it when it's cold, right? Do your grandparents, oh, it's so cold outside, my whole body hurts, right? Yeah, they do that. They do. Or they make it so hot in their house, you go over there and you roast. Yeah. Okay, so they like it warm. So in other words, they like Florida. And Florida, let me tell you what the percentage in Florida is of old people, is 17.3% of the population is old people, 65 or older. I won't say old people, 65, who knows? You don't call that old. Anyways, so what we're going to do is we have it for all 50 states. And it's this crazy chart, and I can show it to you. It's right here. It has the percentages of everybody, all the states, okay? And they want us to make a stem and leaf plot for this data. So let me show you how you would do that for this problem. What you want to do is you're going to have a stem over here, and then you're going to have a leaf on this side. A stem and a leaf. Okay? Your stem's going to be your first digit. So if you look at the percentages, if you were to look, the first digit, the smallest first digit is 7.7%. That's the smallest percent from Alaska. Then you're going to write a 7 here. Okay? And then you're going to write an 8. You're not going to skip anything. So this is going to be, your stem is going to be the first digit of the number. So 7, 8, 9, 10. I know I say digit, but it can be digits. 11, 12. Okay, and you're just going to keep going all the way up to the most, which was 17. All right? And then for the leaf, what you're going to do is, see, Alaska was 7.7. I would put a 7 here. And that's the only one that started with a 7%. There were no 8% in the list, okay? There was a 9%, and it was a 9.0. I'm not sure what state that was, but it's 9.0. So at 9, I put a 0 there. Okay. For the 10%, there was a 10.3, a 10.7, and a 10.9. And so what you do for the stem of a 10, there's going to be 3 leaves for that. And you want to write them in order. 3, 7, 9. And you also want to keep your columns the same too. Okay? So for 11, 11 is crazy. There's a lot of 11%. So 11%, there was, no, 11 was just 1. Sorry, 11 was just 1, which was 11.4. 12 is the one that has a ton. 12 had 12%. It had a 12.2%. And then it had 3 12.3%. So you have to list all 3 of them. Okay? It also had 12.4%. It had a 5, an 8, and 2 9s. Crazy, right? Okay. Yeah. And then 13 had even more. 14 had, okay. And then once you get down to 17, 16 had a 16.0, and 17 was 17.3. So that's what a stem and leaf plot looks like. Now, why in the world do we want to waste our time and write all those numbers out, right? Well, the stem and leaf plot shows you the distributions. It shows you that, you know, this is like almost like a bar chart on the side here. And it goes way out. That's why you list them all, so that you can see, oh, that one's just 1 and that one's just 1 too. Okay? So that's how you make a stem and leaf plot they're going to ask you to do that. All right, for number 2, that was number 1. Did I say that was number 1? No. Number 1. All right, for number 2, this is going to be a little bit better because there's not as many statistics for this one. All right, so do you watch baseball at all? Did you watch baseball? Have you watched baseball? No? All right, this is a back-to-back stem and leaf plot. All right, so I'm going to give you two people in history that were baseball players. There was a guy named Babe Ruth. Have you ever heard of him? I sure hope so. And then there was also Barry Bonds. Have you ever heard of him? No? So Babe Ruth and Barry Bonds. Babe Ruth was a long time ago. Barry Bonds was like, 2001 era, right around there, okay? So this is going to be the total home runs that they hit. So Babe Ruth, in his first year of playing baseball, hit 0 home runs. The next year he hit 1, and then 3, and then 3, and then 11, 29, 54, 59, 35, 41, 46, 25. Okay, the list goes on. Okay, it goes on a lot until finally, at the end of his career, his last year, he hit 6. All right, Barry Bonds, his first year as a rookie, he hit 16 home runs. That's pretty impressive. And then he hit 25, 24, 19, 33, 25, 34. Okay, the list goes on and on. And finally, his last year, he hit 28 home runs. Okay, now what they want us to do is they want us to make a back-to-back stem and leaf plot for this, okay? So this is how you do it. You're going to have Babe Ruth on this side. You're going to have Barry Bonds on this side. Okay? It's getting warm in here, huh? Now, on the middle part's going to be your stem. Okay? The lowest number is 0. So I'm going to put 0 as my first digit. That'll include things like 01, 02, 03, 04. Then I'm going to have a 1, because that's going to include things like 10, 11, 12 to 19. And then a 2. And I got to go all the way up to 7. Because Barry Bonds, the most home runs that was hit between the two of them was 73, and that was Barry Bonds. 3, 4, 5, 6, and 7. Okay, so Babe Ruth. He hit 0, 1, 6, 3, and 3. So here's how you want to list Babe Ruth. You want to put his numbers going that way, okay? So 0, 1, 3, 3, 6. Barry Bonds had 1 year where he only hit 5 home runs. And that was it. Okay, so now for 10 through 19. Babe Ruth 1 year hit 11 home runs. Barry Bonds hit 16 1 year and 19 another year. And that's how you do it, okay? For the 2s, Babe Ruth hit 22 home runs, 25 home runs, and 29 home runs. And I'm trying to keep these all in the same column. It's kind of hard for me because there's no lines there. Barry Bonds hit 24 home runs, 25, 25 again, 26, and 28. So you get the idea of what we're doing, the stem and leaf plot? Okay, let's do a couple more. Barry Bonds hit 34 and 35. Babe Ruth. And Barry Bonds hit 33, 33, 34, 34, 37, 37. Okay, and then finally at the very end, Babe Ruth, the most he ever hit was 60, and the most Barry Bonds ever hit was 73. And then there's some numbers in between, okay? So you form a back-to-back stem and leaf plot, and then they might ask you some questions like who hit the most, or I don't know. And that's the thing about statistics, is you could have some data and you could interpret it a different way than somebody else would. And that's sometimes the problem too. Okay, so that's stem and leaf plots. Have you guys done that before? Anyone ever done that before? Yeah? I think HAT did that, but regular algebra 2 did not. Okay, let's move on. Part C now. Part C is going to be histograms. Histograms. Okay. And what this does is this is going to display your stuff in a frequency table. Frequency table, and we're going to let our calculators do a lot of this. Okay? So I hope you have your calculator. So what you're going to do with this, let's do number 3. Let's make a histogram of Babe Ruth's annual home run totals using intervals of width 10. Okay? So we're going to do Babe Ruth's home runs and intervals of 10. All right, so here we go. You're going to get your calculator out, and we're going to let our calculator do all of this. I'm not recording the calculator, but I'm recording like what goes with the calculator. All right, so you go to Stat, Statistics, and we're going to edit our list. So go up and clear anything that you have in L1 or L2. Don't hit delete, hit clear, enter, clear, enter. And we're going to list all of Babe Ruth's home runs. So I'm going to just call them out. I hope you can stay with me. I won't go too fast, okay? So here they are. 0, 1, 3, 3, 11, 29, 54, 59, 35, 41, 46, 25, 47, 60, 54, 46, okay, a few more, 49, 46, 41, 34, 22, and 6. He played a lot of seasons, 22 years. Wow, really? That's crazy. Okay, now we're not going to put anything in L2 at all. Have you ever done that before? No? Maybe? Okay, so what you're going to do now is you're going to go to your window. Okay, your window might be negative 10 to 10, something like that. You're going to let x min, oh, sorry, I'm in parametric functions. Also clear anything that you have in y1, y2. All right, so we're going to let x min be 0. And then you're going to let x max be 70. Oops. 70. Okay, x scale, we're going to have our scales go by tens. X scale is 10. And then for the y's, what did they say for the y's? Well, we'll go from 0 to 10 for the y's, okay? All right, so now you're going to go to second stat plot. Second stat plot. And we're going to hit enter. Normally, the type of graph that you do is that first type, which is the scatter plot points. We're not going to do scatter plot. Oh, first of all, we can turn it on from here. And we want to do a frequency table, a histogram. Looks kind of like a bar chart, like that. So choose that one. And then what it does is it'll say X list L1 frequency 1. Okay? And I think if you hit zoom 9, yes. Oh, did I just change my window by doing that? I did. Don't hit zoom 9. I'm sorry. 0 to 70, 10. Then hit graph. Okay, I want my intervals in 10. When I hit zoom 9, they gave me my intervals as 12, but I don't want intervals as 12. I want it 10. So I want 0 to 10, okay? And you can even hit trace, and you can trace this. So there's 5 of them. And if you look at that, that stem and leaf plot, we had 5 points for that first interval, which was 0. Okay, and then the next one, there was only 1 there. That was when he hit 11 home runs. And then the next one would be 20, or the minimum's 20. So that's n equals 3. There's 3 of them there. Okay? And then they would want you to just like draw the chart that you see. So you'd go like this. This right here is 10, 20, 30, 40, 50, 60. Okay. And then 1, 2, 3, 4, 5. There you go. It's a frequency table. It's telling you how many times, how many home runs he had. You don't have to draw those in. How many home runs he had from 10 to 20. And then he only had one home run between 10 and 20. Or 5 from 0 to 10, 1 from 10 to 20. And then the next one was 3. 3 home runs from 20 to 30. Okay? And then the next one, and so on. You just draw your stuff. Did I go up high enough? Yeah, this was 7. Between 40 and 50, this one was 7. That was the most he hit. Now you can have all different kinds of shapes of these. We're running out of time. And I'm not really going to test you on that, but they could be like skewed to the right, skewed to the left. Most of the time, though, when you do statistics, it's like pretty much in the middle, and then it kind of tapers off like a bell curve almost. Okay, and then the last one that I just don't think that we have time for today are time plots. And we're just going to have to not do those today. Okay, so time plots to be continued.